Hello, my name is Gary Templeton. This lecture is on information technology acquisition. This lecture on IT acquisition delves into essential topics shaping the landscape of technology procurement and development. Throughout this lecture, we will explore various facets of IT acquisition, starting with an examination of different strategies organizations employ to procure, implement, and manage information technology resources effectively. We'll then delve into the traditional software development lifecycle, or SDLC, understanding its structure, phases, and nuances, followed by an exploration of its strengths and limitations in today's dynamic business environment. Next, we'll uncover modern development approaches such as Agile, DevOps, and Lean, and their transformative impact on software development practices. Additionally, we'll discuss information systems valuation methods, including return on investment and net present value, to assess the financial worth of IT investments. Finally, we'll explore emerging trends in IT acquisition, including cloud computing, artificial intelligence, and cybersecurity considerations, shaping the future of technology acquisition strategies. IT acquisition refers to the process of procuring new information technology capabilities within an organization. It encompasses the planning, evaluation, selection, and purchase of hardware, software, and services to meet the operational, tactical, and strategic objectives of the organization. Effective IT acquisition involves aligning technology investments with the mission, strategy, and goals of the organization. To accomplish alignment, managers consider factors such as functionality, cost, scalability, security, and compatibility with existing systems. In today's dynamic business environment, IT acquisition plays a crucial role in organizational learning, which relates to its ongoing innovativeness and enhancing productivity, efficiency, and competitive advantage. The landscape of technology adoption within organizations is undergoing rapid evolution, fueled by advancements in digital capabilities and shifting market dynamics. Traditional approaches to technology adoption are being challenged as businesses constantly respond to ever-changing customer demands and competitive pressures. As examples, cloud computing, artificial intelligence, Internet of Things, and blockchain are key information technologies reshaping the way organizations operate. Embracing these technological movements requires organizations to adapt their IT acquisition strategies, focus on new competitive factors such as flexibility, interoperability, and scalability, and stay ahead in the digital age. IT acquisition holds significant importance for organizations across various industries, serving as a cornerstone for driving innovation, enabling growth, and enhancing competitiveness. In today's interconnected world, where technology underpins nearly every aspect of business operations, effective IT acquisition strategies are essential for harnessing the power of digital solutions to streamline processes, optimize performance, and deliver value to customers and stakeholders. With a strong IT acquisition capability, organizations can make more informed decisions about IT investments, leverage cutting-edge technologies to improve productivity, foster collaboration, mitigate risks, and seize new market opportunities. The result can be a better position for long-term success in a rapidly evolving business landscape. IT acquisition strategies encompass a range of approaches aimed at effectively acquiring and deploying technology resources to meet organizational objectives. These strategies may include a comprehensive needs assessment, thorough market research, vendor evaluation, and risk analysis to ensure alignment with business goals and optimal return on investment. Organizations often employ a mix of tactics such as outsourcing, insourcing, leasing, and purchasing to build a diverse IT portfolio that addresses their unique requirements while also remaining adaptable to evolving technological landscapes and market trends. The build versus buy decision is a critical consideration in IT acquisition, involving the evaluation of whether to develop solutions in-house or purchase them from external vendors. Organizations weigh factors such as cost, time to market, expertise, customization requirements, and long-term maintenance when making this decision. While building custom solutions offers greater control and customization, it can be resource-intensive and time-consuming. On the other hand, buying off-the-shelf solutions can provide faster implementation and access to specialized expertise, but may require compromises in functionality or integration. Striking the right balance between building and buying is essential to optimize IT investments and achieve strategic objectives effectively. Vendor selection and management are integral components of IT acquisition, involving the identification, evaluation, and engagement of external suppliers to fulfill technology needs. Effective vendor selection requires thorough due diligence, including assessing vendor reputation, financial stability, technical capabilities, service levels, and alignment with organizational values and objectives. Once vendors are onboarded, proactive management practices such as contract negotiation, performance monitoring, relationship building, and periodic review ensure that vendors deliver value, adhere to contractual obligations, and remain responsive to evolving business requirements. Cloud adoption and the emergence of IT as a service are transforming the way organizations acquire, deploy, and consume IT resources. Cloud computing offers scalable, on-demand access to a wide range of services and infrastructure, enabling organizations to reduce capital expenditures, increase flexibility, and accelerate innovation. IT as a service models further extend these benefits by providing a consumption-based approach to IT provisioning, where resources are delivered as services tailored to specific business needs. Embracing cloud adoption and IT as a service requires organizations to reassess their IT acquisition strategies, focusing on agility, cost optimization, security, and governance to harness the full potential of cloud technologies while mitigating associated risks. The traditional software development lifecycle, or SDLC, is a structured methodology used by software development teams to acquire software applications in a systematic manner. Rooted in sequential and linear approaches, the traditional SDLC typically consists of distinct phases, each with its own set of activities and deliverables. It provides a framework for managing the entire software development process, from conception to deployment, while emphasizing the importance of documentation, quality assurance, and stakeholder involvement at every stage. While variations exist, the traditional SDLC generally follows a linear progression, with each phase building upon the outcomes of the preceding one, thus ensuring a methodical and controlled approach to software development. The SDLC encompasses several key phases that guide the systematic development and deployment of software applications. These include the planning, analysis, design, implementation, and maintenance phases of development. Together, these SDLC phases provide a structured framework for managing software projects, promoting collaboration, efficiency, and quality throughout the development lifecycle. Each of these phases will be described on the next several slides. The planning phase of the SDLC is the initial phase where project objectives, scope, timelines, and resource requirements are defined. It serves as the foundation for the entire development process, setting the direction and framework for subsequent activities. During this phase, stakeholders collaborate to establish clear and achievable goals, identify potential risks, and outline strategies for mitigating them. Additionally, the planning phase involves assembling the project team, allocating responsibilities, and defining communication protocols to ensure effective coordination and collaboration throughout the development lifecycle. One of the key roles of the planning phase is to control software quality and cost by laying out a comprehensive roadmap for the project. By conducting thorough requirements analysis and risk assessment, project teams can identify potential challenges early on and implement strategies to address them proactively, thus minimizing the likelihood of costly rework or delays. Moreover, effective planning enables teams to allocate resources efficiently, optimize workflows, and adhere to budgetary constraints, contributing to overall cost containment and project success. A compelling real-world example highlighting the importance of the planning phase in project success is the development of the London Olympics 2012 website. The organizing committee faced the daunting task of creating a dynamic online platform to provide comprehensive information, ticketing services, and interactive features for millions of users worldwide. Through meticulous planning, the project team conducted extensive stakeholder consultations, defined clear requirements, and established a robust project plan encompassing design, development, testing, and deployment phases. By prioritizing user experience, scalability, and security from the outset, the team successfully delivered a feature-rich website that effectively engaged audiences and facilitated seamless access to critical information throughout the event. The thorough planning process not only ensured the timely delivery of the project, but also helped control costs and mitigate risks, demonstrating the pivotal role of the planning phase in achieving project objectives and stakeholder satisfaction. The analysis phase of the software development lifecycle is a crucial phase focused on gathering, analyzing, and documenting detailed requirements for the software system under development. This phase involves collaborating closely with stakeholders to understand their needs, business processes, and functional specifications. The primary goal is to establish a comprehensive understanding of the system's functionality, performance expectations, user interactions, and integration requirements. Through techniques such as interviews, surveys, document analysis, and workshops, analysts collect and prioritize requirements, identify potential constraints, and clarify ambiguities to ensure alignment between the software solution and the organization's objectives. Additionally, the analysis phase serves as the foundation for subsequent design and development activities, providing developers with clear guidelines and specifications to translate requirements into actionable solutions. By meticulously defining system requirements and user expectations, the analysis phase plays a pivotal role in controlling software quality and cost. It helps identify potential risks and dependencies early in the project lifecycle, enabling teams to address them proactively and minimize the likelihood of costly rework or scope creep later on. Moreover, by fostering a shared understanding of project objectives and deliverables among stakeholders, the analysis phase helps mitigate misunderstandings and ensure that the final product meets expectations within the allocated budget and timeline. A compelling real-world example that underscores the importance of the analysis phase in project success is the development of the healthcare information system by a leading hospital network. Faced with the challenge of modernizing its outdated patient management system, the hospital embarked on a comprehensive analysis phase to assess current workflows, identify pain points, and define future requirements. Through extensive consultations with healthcare providers, administrators, and IT specialists, the project team gained insights into the complex interplay of clinical processes, regulatory requirements, and user needs. By documenting detailed functional and non-functional requirements, the analysis phase provided a solid foundation for system design and development, ensuring that the new solution addressed critical pain points while adhering to industry standards and compliance mandates. As a result, the hospital successfully deployed a state-of-the-art information system that streamlined patient care, improved operational efficiency, and enhanced data security, underscoring the pivotal role of the analysis phase in driving project success and stakeholder satisfaction in complex domains like healthcare. The design phase of the SDLC is a critical phase focused on transforming the requirements gathered during the analysis phase into a detailed blueprint for the software solution. It involves creating a comprehensive design that encompasses system architecture, data structures, user interfaces, modules, and algorithms. During this phase, software architects and designers collaborate to translate functional and non-functional requirements into technical specifications and design elements. The design process may involve several iterations, reviews, and validations to ensure that the proposed solution aligns with stakeholder expectations, industry standards, and best practices. Additionally, the design phase aims to address key quality attributes such as scalability, maintainability, reliability, and performance, laying the groundwork for a robust and sustainable software solution. By fostering a clear understanding of system components, interactions, and dependencies, the design phase plays a crucial role in controlling software quality and cost. It helps identify potential design flaws, inefficiencies, and bottlenecks early in the development lifecycle, enabling teams to make informed decisions and optimize resource allocation. Moreover, by providing a roadmap for implementation, testing, and deployment, the design phase helps streamline development efforts, minimize rework, and mitigate risks, thereby contributing to overall project success and stakeholder satisfaction. A compelling real-world example that underscores the importance of the design phase in project success is the development of the SpaceX Falcon 9 rocket software. As part of its ambitious space exploration program, SpaceX faced the daunting task of designing and implementing complex software systems to control various aspects of rocket launch, flight, and landing operations. During the design phase, SpaceX engineers meticulously crafted detailed architectural designs, algorithms, and interface specifications to ensure the reliability, safety, and performance of the Falcon 9 software. By leveraging simulation tools, modeling techniques, and rigorous testing methodologies, the design team identified and addressed potential failure scenarios, edge cases, and performance bottlenecks, mitigating risks and ensuring mission success. The robust design architecture laid the foundation for a highly reliable and reusable rocket system, enabling SpaceX to achieve unprecedented milestones in space exploration while controlling costs and optimizing resource utilization. The success of the Falcon 9 program highlights the critical role of the design phase in translating ambitious visions into tangible, scalable, and sustainable software solutions in complex and demanding environments like aerospace engineering. The implementation phase of the SDLC marks the phase where the actual coding and development of the software system take place based on the requirements and designs established in earlier phases. It involves translating the detailed specifications and design documents into executable code, modules, and components. During this phase, developers write, compile, and integrate code according to predefined coding standards, guidelines, and best practices. The implementation process often involves collaborative efforts among developers, testers, and other stakeholders to ensure that the software meets functional requirements, adheres to design specifications, and maintains compatibility with existing systems and technologies. Additionally, the implementation phase encompasses activities such as unit testing, integration testing, and debugging to identify and resolve defects, inconsistencies, and performance issues early in the development lifecycle. By focusing on code quality, adherence to standards, and efficient resource utilization, the implementation phase plays a crucial role in controlling software quality and cost. It enables teams to detect and address defects and deviations from specifications before they escalate into costly rework or system failures. Moreover, by fostering a disciplined approach to coding, documentation, and version control, The implementation phase helps streamline development efforts, reduce time to market, and enhance overall project efficiency and effectiveness. A compelling real-world example that highlights the importance of the implementation phase in project success is the development of the Android operating system by Google. As the world's most widely used mobile operating system, Android powers billions of smartphones, tablets, and other smart devices globally. Throughout its development lifecycle, the Android team prioritized the implementation phase to ensure code quality, reliability, and performance across diverse hardware platforms and device form factors. By adhering to stringent coding standards, modular design principles, and rigorous testing methodologies, the Android development community consistently delivers high-quality releases that meet the evolving needs and expectations of users and developers worldwide. The robust implementation practices employed by the Android team not only contribute to the platform's stability and performance, but also enable seamless integration with third-party applications, services, and hardware components, driving innovation and growth in the mobile ecosystem. The success of Android underscores the critical role of the implementation phase in delivering scalable, reliable, and feature-rich software solutions that empower users and drive digital transformation across industries and domains. The maintenance phase of the SDLC represents the phase where the software system is deployed into production and undergoes ongoing support, enhancements, and optimizations throughout its lifecycle. It involves activities such as monitoring system performance, addressing user feedback, resolving defects, and incorporating new features or functionality to adapt to changing requirements or technology landscapes. The maintenance phase aims to ensure the long-term viability, reliability, and usability of the software solution, thus maximizing its value and return on investment. Moreover, the maintenance phase plays a critical role in controlling software quality and cost by addressing issues and improving efficiency over time. It allows organizations to proactively identify and rectify defects, security vulnerabilities, and performance bottlenecks, thereby minimizing the risk of system failures, downtime, or data breaches. Additionally, by implementing preventive maintenance measures such as code refactoring, documentation updates, and performance tuning, organizations can optimize resource utilization, extend system lifespan, and reduce total cost of ownership over the software's lifecycle. A real-world case example illustrating the importance of the maintenance phase toward project success is the evolution of the Microsoft Windows operating system. As one of the most widely used operating systems globally, Windows undergoes continuous maintenance and updates to address security vulnerabilities, compatibility issues, and user experience enhancements. Through regular patch releases, service packs, and feature updates, Microsoft's maintenance efforts ensure that Windows remains secure, stable, and functional across diverse hardware configurations and usage scenarios. For instance, the Windows Update service delivers critical security patches and bug fixes to millions of users worldwide, safeguarding systems against emerging threats and vulnerabilities. Moreover, the Windows Insider program allows users to provide feedback and test pre-release versions of Windows, enabling Microsoft to identify and address issues before they impact a broader user base. The proactive maintenance practices employed by Microsoft not only enhance the reliability and performance of Windows, but also demonstrate the company's commitment to delivering a secure and seamless computing experience for users across the globe. The success of Windows underscores the significance of the maintenance phase in ensuring the longevity, reliability, and usability of software solutions in a constantly evolving technological landscape. The traditional SDLC offers several strengths that have made it a widely adopted methodology in software development. One of its key strengths lies in its structured and sequential approach, which provides a clear roadmap for project planning, execution, and management. the traditional SDLC emphasizes comprehensive documentation, thorough requirements analysis, and rigorous testing, ensuring that software projects are well-defined, controlled, and predictable. This methodology also promotes stakeholder involvement and collaboration at various stages of the development lifecycle, fostering transparency, alignment, and accountability. Moreover, the traditional SDLC is adaptable to diverse project requirements and organizational contexts, making it suitable for a wide range of software development scenarios, from small-scale projects to large enterprise solutions. By leveraging these strengths, organizations can mitigate risks, optimize resource utilization, and deliver high-quality software solutions that meet stakeholder expectations and business objectives effectively. Despite its strengths, the traditional SDLC also possesses several weaknesses that can pose challenges in today's dynamic and rapidly evolving business environment. One notable weakness is its inherent rigidity and inflexibility, which may limit the ability to respond quickly to changing requirements, market conditions, or technological advancements. The sequential nature of the traditional SDLC can result in lengthy development cycles, delaying time to market, and inhibiting innovation. Moreover, the emphasis on extensive documentation and upfront planning may lead to bureaucratic overhead and administrative burden, diverting resources away from actual development efforts. Additionally, the traditional SDLC may struggle to accommodate iterative and agile development methodologies, which prioritize adaptability, collaboration, and responsiveness over rigid processes and documentation. As organizations strive to stay competitive and agile in today's digital landscape, the limitations of the traditional SDLC underscore the need for alternative approaches that emphasize flexibility, speed, and continuous improvement to meet evolving customer demands and market dynamics. Modern information technology development approaches encompass a diverse array of methodologies and practices designed to address the complexities and challenges of today's digital landscape. The strengths of modern development approaches over traditional SDLC methodologies lie in their adaptability, responsiveness, and emphasis on collaboration and continuous improvement. Unlike traditional SDLC, modern approaches such as Agile, DevOps, and Lean prioritize flexibility, allowing teams to iterate rapidly and adjust to evolving requirements and market conditions. These methodologies promote close collaboration between developers, stakeholders, and end users, fostering transparency, alignment, and shared ownership throughout the development process. Moreover, modern approaches emphasize automation, continuous integration, and delivery, enabling organizations to accelerate time to market, enhance product quality, and reduce cycle times. By fostering a culture of innovation, experimentation, and customer centricity, modern development approaches empower organizations to stay competitive, drive innovation, and deliver value-driven software solutions that meet the ever-changing needs and expectations of customers and stakeholders effectively. While more modern approaches have their merits, the traditional SDLC remains an important factor in IT development when the final deliverable is large and has greater implications. Agile methodology is an iterative and incremental approach to software development that prioritizes adaptability, collaboration, and customer feedback throughout the project lifecycle. It emphasizes the delivery of working software in short, frequent iterations, allowing teams to respond quickly to changing requirements and stakeholder needs. Agile frameworks such as Scrum, Kanban, and XP, which is extreme programming, promote self-organizing, cross-functional teams that collaborate closely with customers to deliver value incrementally. By embracing flexibility, transparency, and continuous improvement, Agile methodologies enable organizations to optimize resource utilization, mitigate risks, and deliver high-quality software solutions that meet evolving business objectives and user expectations effectively. DevOps practices represent a cultural and technical movement that aims to bridge the gap between software development and IT operations, promoting collaboration, automation, and continuous delivery across the entire software development lifecycle. DevOps emphasizes shared responsibilities, streamlined workflows, and feedback loops to accelerate software development, improve system reliability, and enhance overall organizational performance. Key DevOps practices include infrastructure as code, continuous integration, continuous delivery, automated testing, and monitoring. By breaking down silos, fostering a culture of collaboration, and embracing automation, DevOps enables organizations to deliver software faster, more reliably, and with greater efficiency, thereby enhancing agility, innovation, and customer satisfaction. Lean development is a software development approach inspired by lean manufacturing principles, focusing on maximizing customer value while minimizing waste, inefficiencies, and unnecessary work. It emphasizes the elimination of non-value-added activities such as overproduction, waiting time, defects, and excess inventory to streamline workflows and optimize resource utilization. Lean development encourages teams to prioritize customer needs, continuously improve processes, and empower individuals to make data-driven decisions. By fostering a culture of continuous learning, experimentation, and collaboration, lean development enables organizations to deliver high-quality software solutions that meet customer expectations, drive innovation, and achieve sustainable competitive advantage in today's dynamic business environment. Continuous integration and continuous delivery, CI/CD, is a software development practice that emphasizes automating the integration, testing, and deployment of code changes to deliver high-quality software rapidly and reliably. In CI/CD pipelines, developers frequently merge code changes into a shared repository, triggering automated builds, tests, and deployments. Continuous integration ensures that code changes are integrated smoothly, allowing teams to detect and address defects early in the development process. Continuous delivery extends CI by automating the release process, enabling teams to deploy code changes to production environments quickly and safely. By streamlining development workflows, reducing manual interventions, and promoting collaboration across teams, CI/CD enhances software quality, accelerates time to market, and improves overall development efficiency, empowering organizations to innovate and adapt to changing market demands effectively. Rapid application development, or RAD, is an agile software development approach that emphasizes iterative prototyping, user feedback, and rapid iteration to accelerate the delivery of software solutions. Unlike traditional development methodologies, RAD prioritizes speed and flexibility, enabling teams to develop and deploy functional prototypes quickly, to gather user feedback and refine requirements iteratively. RAD frameworks such as Scrum and Extreme Programming emphasize close collaboration between developers and stakeholders, leveraging rapid prototyping, modeling tools, and reusable components to expedite development cycles and reduce time to market. By embracing RAD principles, organizations can adapt to changing business needs, reduce development costs, and deliver innovative software solutions that meet customer expectations effectively in dynamic and competitive environments. Modern development approaches offer several benefits that cater to the evolving needs of software development in today's dynamic environment. These methodologies prioritize collaboration, flexibility, and adaptability, enabling teams to respond quickly to changing requirements and market demands. By emphasizing iterative development, customer feedback, and continuous improvement, modern approaches such as Agile, DevOps, and lean enable organizations to accelerate time to market, enhance product quality, and foster innovation. Moreover, modern development practices promote cross-functional teams, automation, and transparency, fostering a culture of accountability, ownership, and shared responsibility. By leveraging modern development approaches, organizations can optimize resource utilization, mitigate risks, and deliver value-driven software solutions that meet customer expectations and drive business growth effectively. However, modern development approaches also present several challenges that organizations must navigate to realize their full potential. One significant challenge is the cultural shift required to adopt and sustain modern methodologies such as Agile and DevOps. Embracing collaboration, transparency, and continuous improvement often requires changes in mindset, organizational structure, and management practices, which can encounter resistance and skepticism from stakeholders accustomed to traditional ways of working. Moreover, implementing modern development practices requires investments in training, infrastructure, and tools to support automation, integration, and collaboration effectively. Additionally, scaling Agile and DevOps across large, distributed organizations poses logistical and cultural challenges as maintaining alignment, communication, and consistency becomes increasingly complex. Furthermore, ensuring security, compliance, and governance in fast-paced development environments presents additional challenges, requiring organizations to balance speed and innovation with risk management and regulatory requirements effectively. Addressing these challenges requires strong leadership, cultural transformation, and a strategic approach to enable organizations to fully leverage the benefits of modern development approaches while mitigating associated risks and complexities. Information systems valuation methods encompass a variety of approaches used to determine the financial worth or value of information systems within organizations. These methods typically involve assessing both tangible and intangible aspects of the system's assets, including hardware, software, data, and human resources. By employing these valuation methods, organizations can make informed decisions regarding resource allocation, investment prioritization, and strategic planning, thus optimizing the value and performance of their information systems portfolios. The cost approach, exemplified by methodologies like total cost of ownership, evaluates the financial worth of information systems by considering the expenses incurred throughout the system's lifecycle. This method accounts for various costs associated with the acquisition, implementation, operation, maintenance, and disposal of the system. By meticulously assessing both direct and indirect costs, including hardware, software, personnel, training, support, and downtime, organizations gain insights into the total investment required to procure and sustain the system over time, aiding in informing decision-making regarding resource allocation and investment prioritization. The market approach involves determining the value of information systems by comparing them to similar systems that have been sold or transacted in the market. This approach leverages market data, transactions, and benchmarks to gauge the fair market value of the system based on comparable sales, acquisitions, or licensing agreements. By analyzing market trends, demand-supply dynamics, and competitive landscapes, organizations can benchmark their information systems against industry standards and market norms, providing valuable insights into the system's relative worth and positioning within the marketplace. Comparable company analysis is an example of a market approach to IT valuation. In this method, the value of an IT company or asset is estimated by comparing it to similar companies or assets that have recently been sold or are publicly traded. The income approach focuses on estimating the value of information systems based on their potential to generate income or cost savings over time. This method evaluates the system's future cash flows, revenues, or cost reductions, discounted to present value using appropriate discount rates or capitalization factors. By forecasting the system's revenue-generating capabilities and cost efficiencies, organizations gain a quantitative understanding of the system's financial performance and profitability potential. The income approach enables stakeholders to assess the long-term viability, sustainability, and strategic significance of information systems investments, facilitating informed decision-making and resource allocation strategies. Net present value is a financial technique used to evaluate the profitability of an information systems investment by comparing the present value of expected cash inflows with the present value of cash outflows over a specific period, discounted at a predetermined rate. A positive NPV indicates that the investment is expected to generate more value than its initial cost, while a negative NPV suggests that the investment may not be financially viable. NPV helps organizations assess the long-term financial impact of information systems projects, considering factors such as time, value of money, and risk. Return on investment is a widely used method for evaluating the financial performance of information systems investments. It calculates the ratio of net profit generated by an investment to the initial cost of the investment, typically expressed as a percentage. ROI helps organizations assess the efficiency and effectiveness of their information systems projects by comparing the returns generated against the resources invested. A higher ROI indicates a more favorable outcome, while a lower ROI suggests that the investment may not be generating sufficient returns to justify its cost. Break-even point analysis is a valuation method that identifies the point at which the total revenues from an information system investment equal the total costs, resulting in neither profit nor loss. This analysis helps organizations determine the level of sales or usage required for an information system project to become financially viable. By calculating the break-even point, organizations can assess the risk associated with the investment and make informed decisions regarding pricing, resource allocation, and revenue forecasting. The business case method involves creating a comprehensive business case that includes objective data and subjective judgment to justify the information systems investment. The business case is a document outlining the anticipated benefits, costs, risks, and strategic alignment with organizational goals. This method involves analyzing various aspects of the investment, including its impact on revenue generation, cost reduction, productivity improvement, competitive advantage, and regulatory compliance. By articulating the rationale for the investment and quantifying its potential value proposition, the business case method helps stakeholders evaluate the merits of the investment and make well-informed decisions regarding resource allocation and project prioritization. Several emerging trends in IT acquisition are shaping the way organizations procure, implement, and manage technology resources. First, organizations increasingly leverage cloud computing services to enhance agility, scalability, and cost efficiency. Cloud adoption trends include the migration of workloads to public, private, and hybrid cloud environments, as well as the adoption of cloud-native technologies like containers and serverless computing. Second, the integration of artificial intelligence and machine learning technologies into IT acquisition processes enables organizations to automate repetitive tasks, optimize decision-making, and extract insights from vast data sets. AI-driven solutions are increasingly used in areas such as data analytics, cybersecurity, and customer experience enhancement. Third, edge computing, which involves processing data closer to the source of generation, is gaining prominence in IT acquisition strategies. Edge computing enables real-time data processing, reduces latency, and enhances responsiveness, making it well suited for applications in Internet of Things, autonomous vehicles, and augmented reality. Fourth, with the proliferation of cyber threats and data breaches, cybersecurity has become a top priority in IT acquisition. Organizations are investing in security solutions such as advanced threat detection, encryption, identity management, and security orchestration to protect sensitive data and mitigate risks. Fifth, blockchain technology, known for its decentralized and immutable ledger system, is emerging as a disruptive force in IT acquisition. Organizations explore blockchain for applications such as supply chain management, digital identity verification, smart contracts, and secure transactions, aiming to enhance transparency, traceability, and trust in business processes. Sixth, the Internet of Things continues to expand, connecting an ever-growing number of devices and sensors to the Internet. Internet of Things adoption trends in IT acquisition include the deployment of smart sensors, connected devices, and Internet of Things platforms to collect and analyze real-time data for monitoring, optimization, and automation across various industries. Seventh, subscription-based models, including software as a service, platform as a service, and infrastructure as a service, are increasingly preferred over traditional software licensing models. Subscription-based offerings provide organizations with flexibility, scalability, and predictable costs, driving adoption in IT acquisition strategies. Last, sustainable IT acquisition practices, including energy-efficient hardware, eco-friendly packing, and a responsible disposal of electronic waste, are gaining traction as organizations prioritize environmental sustainability and corporate social responsibility in their technology investments. These emerging trends in IT acquisition reflect the evolving landscape of technology and business needs, shaping the strategies and priorities of organizations worldwide. That concludes this lecture on information technology acquisition. I hope you found it useful. Thanks for watching.